Part A, after adding 10 mils of 0.3 NaOH. So step 1, the number of millimoles of HF to be neutralized is 25 mils times 0.3 millimole HF over 1 milliliter. This is equals to 7.50 millimoles of HF. Step 2, the number of millimoles of OH that will be added within 10 mils is 10 mils times 0.3 OH over 1 milliliter, which equals to 3 millimoles of OH. Step 3, to calculate pH when adding the base, use an ice table. So here I've set up an ice table. For HF, we have 7.5 millimole, negative 3 millimole, and 4.5 mole. H2O, we have 0 millimole, negative 3 millimole, 0 millimole. And for F, we have 0 millimole, 3 millimole, and as well 3 millimole. Step 4. Since that only gives us millimoles, to get concentration, we must divide by the total volume. Total volume is the 25 milliliters of original solution of HF plus the 10 milliliters of NaOH that was added. Therefore, the total volume is 25 milliliters plus 10 mils, which equals to 35 mils. Step 5. The concentration of HF equals 4.5 millimole HF over 3.35 milliliters, which equals 0.1287 moles. The concentration of F equals 3 millimoles of F over 35 milliliters, which equals 0.0857 moles. Step 6. Since an acid and its conjugate base are in equilibrium, we can attempt to use the equation. But for it to work, the ratio of the conjugate base and weak acid must be between 0.1 and 10. Also, the ratio of both the conjugate base and Ka value and the ratio of the acid and Ka value must exceed 100. Step 7. The ratio of F to HF is 0.0857 over 0.1287, which equals 0.666. Step 8. This is between 0.1 and 10. Step 9. The ratio of HF to Ka is 0.1287 moles over 6.6 times 10 to the negative 4, which equals to 195. And the ratio of F to Ka is 0.0857 moles over 6.6 times 10 to the negative 4, which equals to 130. These both exceed 100. Therefore, continue by using the equation pH equals negative log 6.6 times 10 to the negative 4 plus log 0.0857 over 0.1287. And step 10, the pH is 3. So part B, after adding 12.5 milliliters of 0.3 mole of NaOH. Step 1, the millimoles of OH added is 12.5 milliliters is 12.5 times 3 millimoles of OH per milliliter, which equals 3.75 millimole of OH. Step 2, use an ice table. So here I've set up an ice table. As you can see the numbers for HF, I put 7.5 millimoles, negative 3.75 millimoles, 3.75 millimoles. For H2O, I put 0 millimoles, negative 3.75 millimoles, 0 millimoles. And for F, I put 0 millimoles, 3.75 millimoles, 3.75 millimoles. Step 3. To find the concentration, divide by the total volume. Initial volume of HF is 25 milliliters. Addition of NaOH is 12.50 milliliters. Therefore, 25 mils plus 12.5 mils equals 37.5 mils. Step 4. Concentration of HF equals 3.75 millimoles of HF over 37.50 milliliters, which equals 0.1 moles. Concentration of F equals 3.75 millimoles of F over 37.5 milliliters, which equals 0.1 moles. Step 5. Since the amounts of conjugate base and acid are equal, the ratio is 1. We know that log equals 0. Therefore, the ratio of the conjugate base to acid will be 0 as well. Step 6. Therefore, the equation is pH equals negative log 6.6 times 10 to the negative 4. And step 7, pH equals 3.18.